also a bad photo of me looking a little too like edgy. But hey, so I'm Jesse. Okay, thank you. Founder of Newmetric, and we're going to talk about what our company Newmetric is doing. So we are a company solely focuses on developer experience side of things. So we want to become like an end-to-end development platform for Cosmos blockchains in general, and we're going to talk about what we have been building and how we're going to like push out everything. So before we like jump straight onto the actual product side of it, I want to sort of iterate on what it means to sort of encompass the complete life cycle of Web3 development. So like before founding this company, Newmetric, I was a builder myself, like, writing contracts here and there on Cosmoverse. I used to be also part of TFL. I did a bunch of infra stuff. I also partook in the Anchor protocol as well. So, but every time I built something, I felt the need that there's gotta be a better version of the development toolkit or the world surrounding us in terms of how we test or how we make our product really shine. So I'm gonna just talk about that. So in the development phase, obviously you're building everything from 0 to 1. That includes writing a bunch of contracts, like 17 to 20 different contracts, and then writing a lot of tests to make sure that your contract is working up to the expectation. And then you go on to like test your contracts on actual testnet. For example, like Terra or Osmosis, whatever chain. You want to just put all your contracts on testnet and then see how that works, right? And then next phase you're gonna hit is, okay, so I thought testnet is a thing. Yeah, I knew it was a thing, but then it's not always available to you. And as in like the RPC is sometimes down, or like you just simply don't have access to these test networks, like networks that are dedicated to test. But then the other problem with testnet is there's no real user activities on testnet. Like we barely use testnet simply because there's no value, like real intrinsic value to the tokens that are sort of being tossed around in testnet. So that means it's kind of hard to get a real user activities. What that leads to is, let's say your contract or your product is heavily market dependent, as in, say, for example, Quasar or some Levana protocol that depends on the market situations or dynamics. Testing that on testnet is kind of difficult because you need to now fake all these user agents, as in, you gotta behave like 100 different people making the actual trades or LPs and stuff like that, which is all very, very, very time consuming and sometimes very exhausting in the long run. And like we move on to the phase of we actually hit the production, right? That's great. So we somehow got through the huddles of like testing things on testnet actually, and then now we have to face this reality where the RPC on say mainnet is somewhat like shaky, as in not reliable sometimes, and then you need to think about V2s, and V2 usually it means like rewriting part of your contracts so that has a better functionality. But then you basically go back to this middle step where okay, testnet, shit, there's no user, right? And how do you make sure that your new code is say up to the current trend of your protocol, which happens to be on mainnet, so that the V2 or V3, what's coming after, is actually up to the spec and up to the expectation. How do you do that? That's really difficult. And this whole cycle, if you built something already and then running your product somewhere on mainnet, it's going to sound extremely familiar. Or if you're just starting out, it's going to be something that you're going to be facing really often. So, in my opinion, the current development lifecycle has these two problems. It basically comes down to these two problems: availability of the infra that we're testing against, let that be RPC or set of toolings. And the second part is testability. How do we make sure that our contract, which happens to be dealing with whatever sort of assets, like let that be actual asset like Osmo or Atom, that carries value, or let that be NFT, which has some intrinsic value attached, like emotional intrinsic values that people have. How do you make sure that these two things are always correct, and then you know what you're doing, right? So solving these two things is our company, Newmetric's mission. So we have a very obsessive, attitude towards like these two things, like availability and testability. So we basically are trying to solve these problems with two products that that I'm gonna introduce about. The first is, so I'm just gonna restate our mission. So we are here to become the all-in-one development platform that covers all your needs from development to production. That means, let's say you're just starting out to write some set of contracts, and then we're going to be there for you to support a set of toolings that you can use really usefully. And then when you go to actual production, say going on to mainnet, we're going to be still there as your partner for like RPC or whatever tooling that might be needed after that. And we have two products. The first product is called Mesa. So Mesa is an ultra high performance RPC cluster. So in Cosmos land, like we have had some RPC related issues here and there. Like right now it's a bear market, so there are not many actual or not too many users to saturate the RPC cluster that we have around the globe. But not around the globe, but then bull market or users come in, and then we're gonna be soon facing the reality of how unscalable the RPC really is at this point. This is what I like to say. So we use Netflix every single day, and I like to say that Netflix wouldn't be Netflix as we know today if it were slow. As in you don't really expect Netflix to be down or not really giving you the video outputs or delivered to you. And as a product, you just use it, always, you kind of think it's always reliable. With Web3, we are sort of trying to categorize this as the next web or next money or whatever, so web that actually carries money, right? It's not going to happen if it's not faster than now. So I just want to talk about SLA. So SLA stands for Service Level Agreement. This is when you're signing up for a service, like how many of a downtime or how many of a performance you can expect from the provider. Right now, the status quo is that all of us, including all of you, whoever's building on Osmosis or whatever platform, we are largely depending on the infra that are run by, say, community-provided nodes. For example, like even Kepler has their Kepler infra team. Polkachoo, like Lavender 5, all of these great providers who actually happen to be also validating on chain. That's great. But then those are more of a public good, as in like they're just providing like subset of their infrastructure to the community for free out of a goodwill, right? So let's say we hit the next bull market and everyone's like hitting RPC really hard, and then they're also going to have really hard time managing the RPC cluster. And then what they do is they block out certain demographics from the world, or they rate limit you, and then that has negative impact onto your web application because now your web app doesn't have a reliable connection onto RPC. With Mesa, we want to say that so this is like a professional grade RPC cluster that can actually offer you this level of SLA. So 1.9 is about equivalent to like few days in a year. So it's only going to be like down for a few days, but after that it's all going to be like performant and always reliable. We want to make sure that this happens. And how do we do it? Like where are we? Like in terms of product building. And in an internal testing, we were able to like just push out 1 million queries per second. That's impressive because like if you have a node, for example, if you ever ran on a node, the usual say request per second you get is like somewhere between 4,000 to 5,000. obviously depends on the complexity of the queries, but having this level of performance, as in like a million queries per second, that means more than, say, 10 million people making like their wallet balance queries like every single second, and it's still going to be fine. Like we're still going to be able to support that level of bandwidth. And then we have the fully elastic sort of backend. We're not going to obviously spend or spin up a bunch of nodes, like 100 or 200 nodes, and then serve it, because that's going to nearly bankrupt us. So we have we developed a solution where everything is like fully elastic. So when there's idle time, it sort of scales down to almost nothing. And then when there's like more bandwidth that's coming into the cluster, it's going to like scale up like linearly to a level where it can actually support million requests per second. So at this point, RPC scalability is pretty much a solved problem, I'd say, because like million requests per second is a lot. Like if you think about it, we have a block duration of 5 to 6 seconds, and then you only get to check certain state every now and then. So this is almost infinity, I'd like to say. So Pocket Network, another great RPC provider, which has decentralized RPC, has put out this RPC trilemma. So basically, RPC trilemma is composed of reliability and performance and cost. So reliability is like really just how reliable the nodes are. Like I said, when you give a little too many traffic to a single node, it's likely going to go down because there's like a lag in consensus or something, so it's likely going to crash something in the node. We don't have the problem because our read nodes, aka the nodes that process the actual queries, are actually completely isolated from the sync nodes, basically. So like no matter how hard you hit our RPC cluster, it's still going to be reliable. Also performance-wise, like I showed you earlier, it's able to push out 1 million requests per second with elastic scalability and improve the latency. We want to leverage our sort of system's cost reduction factor to make sure that the nodes are installed across the globe, so that no matter where you are, you have a fast enough of a connection to RPC. So it's always fast. Your web app is always responsive. Cost. So obviously, we're going to be like a subscription-based paid service, like Alchemy. Think Alchemy for Cosmos. But it's probably going to be cheaper than you running it yourself anyways. So you probably just have to use it. We have a shared storage model. That means our operational cost is kept very, very low. So like we can actually like sustain a set of nodes that are sort of clustered big enough so that it can support whatever bandwidth in the future. And no, we don't. So many people asking me like, how do you actually achieve that level of performance? And people I think generally ask out of their own experience of running the vanilla nodes, like nodes as is. We don't do that. We actually build custom binaries for every single chain. And then we fix basically a lot of concurrency-related issues. We also have failover measures where, so one of our nodes goes down, we have the automatic recovery or disaster recovery measures already in place. And let's say the block is like, it doesn't really happen in Cosmos, but reverted, or something might have gone wrong. Like, let's say we fail to upgrade the node, and then we have a way to say roll back just blocks one by one, so it can like very quickly like catch up and sync again. So we also fix that sort of reliability issues as well, and then we also come with useful default indexes like. On Explorers, you get to see, say, you search by an account, and then all the list of transactions that the account is associated with. We also have those built in. So if you're building some sort of Explorer or like a protocol-specific user history, it's easier for you to do just make that using our default set of indexes. Currently testing. Already have support for 7 chains and more, beta soon. We don't really take too much time to onboard new chains after all, because we developed something we call a common module, so that as long as it's some sort of a Cosmos application that runs on Tendermint or Combat 50, it is compatible. So if you're interested, just talk to me after this. The second product is Cradle. So I've been talking about this on Twitter, or X now, I should call it, a lot recently, and it's what I call the ultimate test environment that forks mainnet. So this is what I like to say. Literally, this is what I told my teammates as I was laying down the first byte of code for Cradle. That's mainnet is the only correct testnet. Like I mentioned earlier, you probably don't want to test things on testnet because the user agents or behavior or even the data or states are sort of never up to the quality of the mainnet, because there's no there's no market. And so Cradle as a product lets you turn a running mainnet into a dedicated devnet, right? What that means is you now suddenly have an access to all the states that has ever happened on mainnet, but we are going to fork it into a dedicated network just only you can access. So you can just send whatever transactions, you can configure the parameters the way you want, everything. And it's a SaaS solution, so everything runs in our cluster. So funnily enough, at least 3 to 4 teams in Cosmoverse this year are doing some sort of main networking thing. But they have to put down a running mainnet and then create a new Genesis file for the fork network. You don't have to do that. You don't have to download anything. You just sign up with our dashboard. This is the UI that you're going to see. So hey, if you want to fork Neutron, you have a Neutron already running. Current height is what? Minimum height is what? You get to set the session name. What is the the height that you want to fork from? You can also designate that. Also, what is the block interval? So this basically means there's zero configuration for you. You just click some buttons, and it's going to be spun up for you. And then it only takes about somewhere between 30 to a minute and a half for boot up. But we have a way to sort of cut it down to say 5 seconds in the future. Battery is included. So the dashboard actually comes with a lot of things. It being a SaaS solution, you don't have the terminal anymore, but we just decided to put everything on dashboard so you can see what's going on the node itself. As you can see, we have little tabs up there, so blocks, transactions, mempool setting. So all these mini explorers are all included. So you can just monitor what's really going on with your fork, or just monitoring the standard output, the console, to see, hey, whether your transaction has failed or succeeded, or you can also check it with your transactions tab as well. Unlike other forks, we also keep the validator set, so you can just you can use other validators that are naturally present on mainnet as a proposer on the forknet. If that matters to you, that's a great feature too. And then you can just click this button. It's going to do something, and then there's going to be a bunch of logs just printed out here, meaning that there's a new block injected to the forknet. So what I really envisioned with Cradle is development should be sort of limitless and frictionless, as in okay, forking is fine, but then if you cannot act on behalf of other wallets that are present on mainnet, there's little to no point of calling in a simulation environment, right? So we also bypassed the signature verification. That means you can act as the wallet that, say, holds the largest LP in whatever osmosis pool, test it with, say, pulling all the LP in that pool, okay? It's not your wallet because you don't have the keys to it, but we just happen to allow those behaviors. So, you can definitely, absolutely test anything or simulate anything on Cradle. Compatible with all the tools you love. So interface-wise, it's almost 99.9% identical to whatever existing nodes out there. So if you're developing with Cosmos.js or whatever toolkit or SDK there might be, chances are you're still going to be able to use it. at this point, imagine what you can do with these tools. And let's say you're done with imagining, chances are you can already do that on Cradle. So contract migration is especially pertinent use cases for this. V2, V3s, you can just frictionlessly test migrations on top of it. Market acceptance tests, especially your contract is super market dependent. You can also do that. We also seen a party before who wanted to run a Monte Carlo simulation, just generating random fake user behaviors onto market and throw them onto the market, see how the contract actually adapts to it. You can also do that. Whale simulator, just for fun, you can do that too. And whatever ideas you might have, you can do with Cradle. We have a workshop today, 2 p.m. In the room Monterosa 1. It's sold out, but I think you can just come by and have a look what's really going on, I guess. So that's it. Thank you for listening. I hope, yeah. I talked to most of you guys. Thank you.